Cool. Cool, this is pretty quick and we finished it at lunchtime. But this is just kind of an overview of our network and how we use MikroTik stuff in it. So GeoNet, we're funded by LINZ and the EQC and some funding from GNS to monitor natural hazards in New Zealand. We're open data policy, so everything, bloody Skype, everything that we collect is freely available to the public. It was established in 2001 to provide information for EQC and their reinsurance purposes. Over time we've made ourselves heaps bigger. And now a lot of people know who GeoNet is when they ask. People trust us, which is cool. We've just sort of investing a lot in our PIM team, and they go around and invest with schools and people to understand how everything works. And we're working with our users and connecting them and making the data that we actually collect as to be useful and used in industry. We're sort of in a bit of a phase at the moment where there's this, if you've heard of the money that MB's dished out for enhanced geohazards monitoring, we're setting up a 24/7 operations centre at the moment. Currently everything's all just paged and on call with no sort of page technical support. That all just sits there with the service. So that's where we're headed. Instrumentation, so we run a network of tsunami gauges around the coast, pressure sensors in the water, a lot of GPS, or as it's now called GNSS networks. We've got 200 odd stations across the country doing that. A bunch of cameras which are mainly used for volcano monitoring, seismometers, measuring earthquakes. That's what we do. We're sort of looking at the moment about gas sampling off the volcanoes and how we can automate that to stop having to put people in places like this. So that's a project we're working on at the moment. There's kind of an overview of our network. It's quite big, plus Rowell Island to the north and Scott Base to the south. Just out of interest, post Kaikoura, we installed a whole bunch of extra stations, and we had that stuff in and operational in the first iteration within a week of the earthquake. We locate a lot of earthquakes every year and they go to the website. We run an automatic location system that runs across the top of all of the data we collect, it'll do an automatic location in less than a minute. One of our targets is we have to have the information on the web within 5 minutes, and it works very well. That's sort of a bit of stats about the stations that we run, the amount of data we collect, which is a lot of data sets, but it's not huge volumes of data per se. Our technologies, how we're using it. This is our kind of network map. It's pretty dense, so you can't really see much detail, sorry. But explanatory, we've got 720 locations where we have equipment across the country, up to 2,500 devices. A lot of MikroTik routers, a lot of MikroTik radios. They make up most of what we do as far as radios go now. A lot of cellular stuff and a few other technologies. When we started building this network, a lot of the cellular wasn't available, so just the expansion of cellular networks alone has been a pretty big benefit to us. There's sort of an overview of our Lower North Island communications network. We were running gear, so likes of the yellow lines are all 5 gig links, the green lines are all 900 meg links, and the orange lines are all 2.4 gig links. And the ones by themselves are either a cell phone or a VSAT. Just some rough ones of our installations. where we're collecting data. So like that's a combination GPS and seismic site on your left, and that's the one on the right is on Rail Island at Boat Cove. So that's running a tsunami gauge, and also you might see the pipes running across on the blocks on the fence posts there. That's what's called infrasound. That's effectively a really sensitive barometer that detects blast waves from the volcano. Some sort of regular sites. Battery Hill and the Wairarapa is again another one of those GPS monitoring sites, and Kaharaniki's effectively really a comms hub. There is a GPS there too. Some more sort of comm sites where we're running gear. Pretty varied, pretty all over the place. Mike, you gonna talk about some stuff?
All right, guys. Hello, I'm Michael. I work for GeoNet for about a year, and I've been asked to give you, just make up a few slides to talk about. So the first thing, you saw that we have 700 sites and more than 2,500 IP addresses in a network. So how do we manage all of that? We use GitHub, and I just love it. It has so many advantages. So as a whole team at GeoNet, we do something you could call as everything as code. So this you could call as infrastructure as a code, let's say. So we have a few files where we keep all the information about our network, what's our IP addresses, locations, circuits, our providers, where everything is going. So it's spread up through few files. But we use Git. We are not big, but there is quite a few people working on our network. And anytime when someone wants to do some change, it needs to go through the tests, which are fully automated. So if you do something wrong, the test will tell you you've done something wrong and you cannot merge it into our database, which is very cool. Then anytime you do request, you pass the test, so you didn't do the mistake. Then you have to ask others to review your work you've done. And they say, okay, maybe you've done something wrong. We can think maybe it could be done better. So try to think about it once again, do another pull request. They will review it. If they like it, then it's approved, and we can merge it all together, and we have one source of truth. On this, we call it network repo. On this, there is connected few other systems. The map you saw just before, is generated from those files. So we don't need to do anything. It's automatically generated, and every time we merge any change in our network, it automatically generates the KML file for our network, There is some processing connected to it as well. So the systems which are processing the collected data, they actually, they know where to ask for data and where to store them and stuff like that. And that would be, and in the future what I'd like to do, I set up the routers at this moment manually, basically just the interfaces and addresses, and then I have a script which will set up everything else. But in the future, what I'd like to do, when I do the pull request and it's been reviewed, I just press the button and it will find the information which been changed, and it will set up the router automatically. That's my goal. One thing, so I started a year ago, and we run OSPF in our network, and there was an issue because the sites are quite remote, inaccessible. Most of them run on a solar, sometimes they have a wind turbine or something like that, but the power is a big issue for us, and the routers go down and up all the time, always. And because we run OSPF, we have OSPF neighbors, and they don't always come up. So every time they don't come up, I need to go all the way there to the router when it's not up and restart the OSPF process. And I was used to do it manually. Now I've just written a script, which I'll describe you later, which will do everything for me automatically. So if it's deployed everywhere, it will check for a status, which is the first, under the first blue line. So it checks for OSPF neighbor. If it's Oh, let's go from the beginning. So we go from 1 to 10. We do not have more than 10 OSPF neighbors, so that's easy, safe number. Then we need to see if the state of OSPF neighbor is initiation or down. We know if it's these two states, it just doesn't work. So then we need to find out what network is it on and what interface. Because of MikroTik how it's done in MikroTik, the OSPF neighbor has the network address, but it's not full network address. It doesn't have /network mask, and there is few other issues which I have solved in intermediate step. So then I want to find out the address. Where is it? So I multiply it by the 255.255.255.0. That means I'll take off the last octet. Then I go to IP address and I compare it to the interface where the OSPF neighbor was found. Then I know that I have particular address, and then I can, the last step, this line, is if I found a network finally, then I need to find out what ID is it in MikroTik system that I can then set ID and restart the network. And that's basically this script. So it's working quite well, and I'm looking forward to deploy it everywhere in our network. It's not there yet. We were testing it for a while. It's working fine, so we'll deploy it soon. Some of our challenges, as you can see, it's exactly the same site, but you cannot see it. So, yeah. So then we lose cons, and then we lose OSPF neighbors, and we can't we can't charge our batteries in a cabinet and stuff like that. So it's fun. Some of our sites, so.
That's the wind.
Strong wind. Some radios, what do we do there?
Yeah, we recently found out there's Kia on Takaka Hill, which we never knew, so we do now. Oh, do they what? They don't like Denso. No one does. Cool. Yeah, again, it's dropped a lot since the price of panels came down, but we used to get panels flogged all the time. And the one on the right is a seismic vault with a fairly expensive seismometer that someone decided to pick up and throw at the ground. So it's the end of that one after cutting the lid off. And yeah, the 900 meg band, we used to use it pretty much almost exclusively, I could say, before people like MikroTik started making products, and they opened the band up, but it's being used by more people. Spillover from cellular sites. This is a screen dump I took at Highcliffe in Dunedin last week, and that's actually when it was running quietly. Normally it's up to -35 all the way down the band from a nearby 2 degrees site. Filters only do so much, and MikroTik stopped making the Metal 9. And that's us. Any questions?
That's us, yeah.
Yep.
Just pick up.
I was wondering, you were saying a lot of your sites got up and down. Do you need to worry about resiliency in the event of a large plate knocking things out, tearing out further meters down, whether you actually that's something you need to restore, or do you need to not worry about those?
So we sort of answer that. Our network's pretty dense in terms of coverage, so that's sort of, rather than build stations hugely resilient, so to speak, we just build lots of them. They are a lot better than when I started there over 10 years ago now. The standards have upped substantially, but then there's some places like that one you saw that there's not really anything else you could do about it, other than potentially now we could put a methanol fuel cell. Now they've come a long way, but yeah.
Thank you.
No worries.
Where do you get your gold bricks to feed the big
You know, there's only 3 at the main. We've just put one at the top of Mount Ruapehu, actually monitoring a site in the Crater Lake, so it's about to hit its 20 megabyte cap for the month, which we're not that happy about.
Have you approached wireless ISPs to maybe piggyback on some of their infrastructure?
Yes,
They've got gear on-
yes, we have with mixed successes. So
Do you guys have a site at Roy's Hill in Hawke's Bay?
at Roy's Hill,
Yes.
yes, we do.
Roy's Hill was.
Okay, it goes to the council in Hastings. Is that us? Sweet. All right. Cheers, guys. Thank you, guys.